Welcome back to our Road to Steam series, a series in which we'll be creating a game from scratch. Previously on our HEUSS dev diaries, we managed to implement arrows in our combat sandbox which allowed us to further advance the depth of our gameplay loop. In today's episode, we'll pick up where we left off and create a basic 3D model of our player, as well as producing some of his animations. If you're interested in more video game behind the scenes like this, join us by subscribing to the channel for exquisite HEUSSian delights. So, without further ado, let's dive right into it. It's been a long time coming, but today we'll finally take our first step into 3D modeling. When you want to model an asset for your game, you cannot do it inside Unity, because the engine does not have the proper tools to do so. Instead, you'll usually use another program that is specifically made for that purpose. In our case, we will be using Blender for the fact that it's free and filled with useful features. Creating a video game character is a multi-step process. Depending on the complexity of the asset, the process may get shorter or a lot longer. For today's character, however, it will be a shorter one. The reason for this is that we don't need a fully fleshed out character at this current point in development. What we need is a simple mannequin-like character that we can animate, so that our combat can have the necessary visual feedback. The plan is to create all the needed combat animations on this mannequin, and later interchange its model with the final one. That way, we don't need to create a new model every time we want to animate a new enemy, which would be time-consuming and not really efficient. What we like to do as a first step is create some reference images of the asset we want to model. By using Krita, we draw a front image of the character and one from the side. We try to keep the proportions between the two perspectives mostly consistent, but if there are some inaccuracies, it's not the end of the world. These drawings do not need to be perfect, as we'll inevitably diverge from them when we start adjusting the model in the later steps. When we're finished with the reference images, it's time to import them into Blender and start bringing our character to life. Every 3D models are made of three basic ingredients: vertices, edges, and faces. Vertices are a single point in 3D space. When two of these points are connected, they form an edge. And when four edges are linked in a closed loop, we get a face. By manipulating these three basic things in various ways, we can create a structure that will represent the shape of our model. This network of points and edges is often called a mesh in the 3D jargon. As we finish the shape of our mesh, we do some small adjustments to its silhouette to correct some strange proportions we couldn't foresee with our reference images. The thing that's left to do is to rig our character. It's basically like creating a skeleton. On its own, a 3D model cannot move in complex ways if it doesn't have one. To create this framework, we'll chain bones together and mimic the structure of a simplified human skeleton. We bind the character's model to it and start assigning bones to specific parts of its mesh. The model's hip area to its hip bone, its head area to its head bone, etc. With our skeleton and mesh linked like this, we can now move our model in various ways and test the limits of human physiology. With that done, it's time to export it to Unity and start the animation process. Normally, we would start to animate our finished model in the 3D software where we created it. We would then export its animations inside Unity to use them in our game. We often use this workflow in game development, because 3D softwares like Blender offer essential tools for creating animations that you cannot find inside game engines. However, the problem with this way of working is that you always need to pass through Blender when you need to create, or make changes to existing animations. So, if you want to animate a character interacting with the environment you've set up inside Unity, you'll need to simulate this environment inside Blender, and go through multiple iterations to get the final result you want. It can become quite cumbersome to work that way. What we need is animation tools that are as versatile as those found in Blender, and with the added benefit of being usable inside the Unity engine. That way, we can avoid the exhausting back and forth when creating animations. The best place to look for these kinds of things is the Unity Asset Store, where people 1,000 times smarter than you create life-saving assets. After some digging and a little bit of existential crisis, we finally found what we were looking for. After setting up U-motion with our character, we can now see all the bones that we've created inside Blender rendered within our scene view. These bones can be manipulated by rotating or moving them to create any pose we want. But that is only the tip of the iceberg. The reason why U-motion is such a godsend is that it can set up an IK rig for you with just the press of a button. In 3D animation, there are usually two ways to animate. FK for forward kinematics, and IK for inverse kinematics. Forward kinematics means that if we move a bone in a chain, it will also move all the bones that depend on it. For a bone to be dependent of another, it needs to be connected to the other's front end. This creates a forward dependencies in the bone hierarchy, hence why this way of animating is called forward kinematics. FK is usually used to animate movement that are in arcs, as the forward dependencies facilitates movements that are rotations. On the other hand, inverse kinematics is the opposite of FK. The dependency of its hierarchy is inverted. So when a bone is moved in IK, it will move all the ones that are behind it in the bone chain. This way of animating is usually used for linear movements like pushing, punching or anything that is in a straight line. With U-motion setting this up for us, we now have all the tools to quickly create professional-looking animations inside Unity. To demonstrate its power, let's make a simple squatting animation. To animate in 3D, you need to take snapshots of the character's pose. By taking multiple snapshots of different poses, and adjusting their position on the timeline, Unity will automatically interpolate between them to animate the character. With a few tweaks here and there, our animation is ready to go. Now that our little animation factory is up and running, it's time to present to you the system that will process these animations during gameplay. This system is divided into two components: the Animation Manager, and the Animator Controller. With each frame of the game running, the engine will execute code related to the game logic first. This encompasses every interactions that can happen during gameplay. Within this period of time, a virtual list takes note of specific flags that get triggered. Things like the player getting hit by an enemy, or the player doing a stomp, etc. When the game logic has finished to execute, it's time for the Animation Manager to take the spotlight. Its purpose is to analyze the virtual list, and tell the Animator Controller how to update its state machine based on it. This state machine can be viewed as a network of animations. It's a way to organize which animation is to be played at any given moment. For it to work properly, the Animator Controller controls which animation state is active by closing and opening transitions in the network. When a specific animation state is active, the associated animation clip is played until it transitions to another state. If done right, this system can organize an infinite number of animations in a clean and understandable manner. It's now time to showcase the current animations we made for our player character. Here's a cocktail of 25 animations on the house. Stay tuned for our 6th episode of our Road to Steam series, where we will cover the progress we'll make on the game in the coming weeks. If you have any feedback or just anything you want to share, don't be shy, and fill the comment section down below. If you enjoyed our content and want to support the channel, feel free to leave a like and subscribe. On this, Godspeed to all of you, and we'll see you on the next episode of our Road to Steam series.
Skulle